Hey everybody, this is Morgan. So we're on page 8 of the AP Chem outline dealing with thermodynamics, and we're continuing the ideas from the last few pages about free energy, spontaneity. So we're going to look at another phase change still. Carbon dioxide solid going to carbon dioxide gas. That is dry ice subliming, and we know that dry ice sublimes at room temperature, which means delta G has to be negative. Now, the entropy change. Solid to gas is a big positive entropy change. And anytime a solid goes to a gas, heat must be absorbed, so that means delta H is positive. And in this case, the entropy is the driving force, not the enthalpy. Now let's look at some different examples. H2 gas becoming 2H gas, room temperature. What we're doing is we're breaking the chemical bond. We're breaking the bond between those two. And you know what? It doesn't happen. Hydrogen does not spontaneously decay into 2H atoms. Now entropy would go up because one particle is turning into two particles, and energy must go in, so delta H is positive. Now, is it possible for a reaction that has a positive delta H and a positive delta S to be spontaneous? The answer is yes, but not at a low temperature like 25 degrees Celsius. It would have to be an incredibly high temperature. Now, how about the opposite idea? Can two nitrogen atoms come together and form a nitrogen molecule? Absolutely, they do. The bond will form. They're more stable when they are together than when they are apart. Delta S would be negative because 2 becomes 1, same phase. And delta H would also be negative because energy is released any time a chemical bond forms. Okay, now, got another example here where a solid and a gas come together to form a solid. What are the signs of? Now, so we'll start with delta S this time. Okay, delta S. Two things becoming one, gas becoming solid, delta S is negative. I know the reaction is spontaneous because it says so, delta G is negative. Now, since delta S is negative, that is not a driving force, but it's a spontaneous reaction. That tells me it has to be exothermic, otherwise it wouldn't be spontaneous. One of these two has to be the driving force, or both of them. But since this wasn't the driving force, that had to be. Now in our last one, the following reaction is highly endothermic. Delta H is positive, very spontaneous. Delta G is negative. Delta S has got to be positive. Otherwise it can't be spontaneous. This is spontaneous. That is not favorable. This has to be. And then when I look at this, wow, 3 moles of solid are becoming 10 moles of liquid, 2 moles of gas, 3 moles of ions floating around in solution. Yeah, delta S is positive. Okay? And actually, that's why you have this. That's such a great driving force. Can the enthalpy be unfavorable and the free energy be favorable? Yes, if the entropy change is very large. So the driving force behind this reaction is delta S. All right, thanks for tuning in. This is Morgan signing off.